solid. Then also solidification, solid state transformation. Wait a moment, maybe I have different slide. Structure. Okay, so this is what the atomic model, which maybe most of you already know, yeah, that you learned in physics as well in chemistry. So most now currently usually we use the model from Niels Bohr, where it has this nucleus, where an atom consists of a nucleus, which basically contains the proton and neutron. Proton has the positive charges, neutron is neutral. Then the surrounding the neutrons, you have this electrons, yeah, revolving around the nucleus, and the electrons are located in the various shells of the atom. There is the electrons located in the first shell, there are electrons located in the second shell, and there are electrons located in the third shell. Yeah? And the first cell can contain up to 2 electrons according to chemistry. Second cell can contain up to 8 electrons. Then the third cell can contain up to 18 electrons. If you remember that using the SPD, yeah, the first shell will be 1s2, that's maximum 2. The second cell can contain 2s2, then 2p6, yeah, up to 8 electrons. Third shell can contain 3s2, 3p6, and 3d. How many? 15. Yeah? Okay. 18 electrons. So this one is 2 plus 6 is 8. So this is 10, up to 10 electrons. And so forth, yeah, with 4s, 4p, 4d, 4f. And usually the flow of the filling order is from 1s, then go to the 2s. Okay, afterwards the 2p and 3s, like this, yeah. Remember, from the chemistry. So this is what is inside the atom itself: the neutrons and the protons and the electron shells. Okay, the electron shell and the electrons that are located in the outermost shell will become the valence electron, the valence electron. And the valence electron, the one this is in the outermost shell, they are responsible for the bonding with other atoms, as well as also the bonding with other molecules. Yeah. So this is important. The valence electron is important. Now this is just what I mentioned. So, for example, hydrogen. Hydrogen is located here in the group 1 and the first row. Yeah, it contains only a single electron. So that electron will fill the first orbital, yeah, the first shell and the first orbital. So we call it 1s1. Helium is here. Okay. In the second, it has 2 atomic number. It has 4 mass. Yeah, the mass number is 4. So it has 2 electrons, which fill all the suborbital in the first shell, the 1s2. So in hydrogen is only 1s1. In helium, it will be 1s2. And the electrons filling the s orbital of the first shell will have 2 different spinning orientation. One is here, it is symbolized is one oriented upward, the other one oriented downward. Then we have lithium. Lithium is here. right? In the second row, in the first column, yeah, 2s. It has 3 electrons, which will fill 1s2, then 1s2 and 2s1, the first orbital in the second shell. Then we have beryllium. Beryllium is here in the second row, in the second column. It has 4 electrons, so 1s2 to s2, right? So it will fill the 1s2 in the different orientation as well as 2s2 orientation. And so forth here with boron. Boron is here in the group 3, second row, yeah, 2p1. This one is only mentioned the last filled orbital. So the orbitals being filled is 1s2, 2s2, and 2p1 here. So the order where the orbitals are filled with electron is like this, as what I have just drawn in the previous slide. So here one is 1, and then it will start to fill the second shell, and first orbital to s, then starting to fill the second orbital p, and of the second shell to p, then starting to fill the third shell, first orbital 3s. And so there are how many quantum number here? There are 4 quantum number here. The shell itself, n. Then the second quantum number is of the orbital, the k, which is the SPD. Then the orientation, of that magnetic of the electron itself. So this is the order of the filling. Yeah, as like this arrow direction: 1s2, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, etc. Yeah, this I believe you have learned in chemistry. So it will be helpful if you can memorize the periodic element of table. You do not need actually to memorize everything, but at least if better if you have memory mnemonic, yeah, to memorize what is in the group 1, what will be in the group 7 here, and what will be in the noble group, noble metal group here. Okay, that will help later to determine whether a compound is, for example, ionic or covalent. Okay, something like that. Okay, so atomic bonding can be of different, of two nature. Though the most many natures. Yeah. The most common or famous atomic bonding is covalent bonding and ionic. Covalent bonding happens when the two atoms share their electrons like this. For example, in oxygen molecule, two two atoms of oxygen. Oxygen is needs another two, yeah, actually to fill completely their shells. So in order to do that, they share the electrons, yeah, here with another atom of electron. So this sharing of electron is called as covalent bonding. So it means each of this electron, the orbital, it flows revolving the two nucleus of the atoms. In ionic, on the other hand, the bonding is caused by very strong electrostatic attraction. So one of the atom will release its electron, causing it to have very positive charges, while the other atom will absorb or attract that electron, making it to be negatively charged. Then binding will occur between the positively charged atom and the negatively charged atom to make ionic bonding. Yeah, we call it positive ion and negative ion. Another binding is called as the metallic bonding. In metallic bonding, it occurs when the electrons in the valence shell, remember what is the definition of valence? Valence means when the electrons are located in the outermost shell. So when it is the electrons in the outermost shell can travel between one atom to another, so jumping around uh, because of very loose binding force from the nucleus, because it's located a little bit far. Because the nucleus itself is quite stable with the innermost shells, electrons, then the outermost electrons, the valence electrons, can travel between atom and atom. And when that happens, in that case, it will form what we call as electron cloud. And this is usually occurs in metallic. This explains why metallic material is electrically conductive. Why? Because their electrons in the outermost shell, their valence electrons can travel easily from one atom to another. So the electrons becomes charge carrier. That that is the carrier of charge. You learn in electrical circuit that electron is actually the one that is traveling in the electrical network. However, usually as a convention, we take the positive charge that is being taken into account as the current, right? And similarly, this also makes metallic material to be thermally conductive because thermal heat energy is also conducted by phonon. Phonon is the vibration of the electrons. Since in this electron cloud, the electrons can vibrate more freely, yeah, compared to those materials that do not have electron cloud, this cause the metallic material to be thermally conductive. They conduct heat easily, more easily than insulating material. So another type of bonding is what we call as dipole. This happens when, as we know, the electron move and travel very fast, yeah, around the nucleus. So sometimes at a moment of time, more electrons are located at this side, for example, which makes this side to be more negative compared to the other side because this side has less electron compared to the space. Similarly, on the other part, on the other atom, one electron also in the left side here. So more negative charge on the left. Negative charge will attract the positive charge of the other atom at one moment of time. And this will cause to what we call as dipole bonding, yeah, between the two electrons. So between the two atoms. But since electrons still move, it is why this dipole bonding does not occur as strong as the covalent or ionic bonding. Okay. So random dipole from the first atom, this is the induced dipole on the second atom. And usually a more common dipole binding you will find in water. Yeah, there is relatively high because there are many electrons here in this side of the oxygen. So that is why it is negatively charged. While the electron in the hydrogen on the other molecule is already shared through covalent bonding with the oxygen in that particular water molecule, which makes this side to be more positively charged. This positively charged side of the hydrogen in this water molecule will make a dipole binding with the negatively charged oxygen on the other water molecule. In water, we call it more specifically as hydrogen bonding. So, but in more general, we call it as dipole bonding. Okay,